Hello, this ERTMS ETCS Learning Module 8 is regarding the design guidance for the ETCS Level 2 Trackside Entities. The design guidance is divided into several modules, thereby, this module is the part 1 of the design guidance. The contents of this learning module was prepared by Christopher Coe, and will be presented with the voice-over, generated from the synthetic voice technology. The contents of this learning module begins with explaining the entities on the trackside, that are visible to the train drivers, in the ETCS Level 2 non-overlay area. Non-overlay means there is no trackside signal, indicator, AWS, or TPWS, when the trains are operating in ETCS Level 2. Then, there are couple sections, explain the differences of RSP, and EOA terminologies, comparing the routes and the movement authorities. After that, this learning module walks through the design processes, for establishing the location of the trackside entities, based on a simple layout. The design process for the location of the ETCS level transition, is excluded in this learning module, but will be included in the separate learning module. First of all, what are the trackside entities, for ETCS Level 2, non-overlay operation? There are three typical trackside entities within the ETCS Level 2 area, that are visible to the train drivers, as shown in the image on the left-hand side. These trackside entities are the ETCS stop marker, the ETCS location marker, and the Euro balise. These trackside entities are known as the interoperability constituents in the TSI. TSI stands for Technical Specification for Interoperability. The ETCS stop marker appearance is a yellow arrow with blue background marker board. The ETCS location marker appearance is a black arrow with white background marker board. The marker board can be located on the left, or right, or above the track. The Euro balise appearance is a rectangular object in yellow color. The Euro balise is located on the track in between rails. There are other marker boards to facilitate the level transition, and traction changeover, which are not shown here. The onboard entity is the ETCS DMI, as shown in the image on the right-hand side. DMI stands for Driver Machine Interface. During the ETCS full supervision operation, the train driver operates the train, based on the information on the DMI in the train cab. The ETCS stop marker, or the ETCS location marker, is for abnormal, or degraded operation, but not for the full supervision operation. The Euro balise is mainly for train position accuracy purpose. The train driver does not require to observe the Euro balise during ETCS Level 2 full supervision operation. The next section of this module explains the differences of RSP and EOA. RSP stands for Route Setting Position. The RSP is the route entry location, depicts on the signaling control workstation, for which a route can be set or revoke. RSP can be marked or unmarked. When the RSP is marked, it can be marked on the trackside, with the ETCS stop marker, or the ETCS location marker. The ETCS stop marker is the yellow arrow with blue background marker board. The ETCS location marker is the black arrow with white background marker board. RSP is the entity associated with the block section authorization in the interlocking system, rather than the movement authority granted by the radio block center. The commencement of the movement authority granted by the radio block center for the ETCS on board is the front end of the train, but not associated with the entity on the trackside or the block section. EOA stands for End of Authority. The EOA is the destination, to which a train is authorized to proceed. The EOA is marked, with a balise group on the track, but not the marker board. EOA is the entity associated with the movement authority, granted by the radio block center, for the ETCS onboard unit, but not the block section authorization, in the interlocking system. The radio block center contains the location information of the link release group, but no information regarding the marker board. The interlocking system does not have location information of the marker board, or the release group. The block section authorization in the interlocking system is primarily based on the train detection section's status, and the position of the point operating equipment. The next section of this module explains the differences of the routes, and the MA. MA stands for Movement Authority. The route category for ETCS Level 2, non-overlay configuration, differs from the color light signaling system. The ETCS Level 2, overlay configuration, retains the trackside signals. Therefore, the route category of the color light signaling system applies to the ETCS Level 2 overlay. For ETCS Level 2 non-overlay, the route category in the interlocking system refers to clear route, occupied route, unproved route, or degraded route. The term class for describing the color light signaling route category is no longer the term for the ETCS Level 2 non-overlay. The clear route is equivalent to the main class, or warning class route, of the color light signaling. The interlocking system for ETCS Level 2 does not require unrestricted overlap, or restricted overlap, for the destination safety margin purpose. The onboard ETCS in full supervision mode supervises and controls the train speed towards the location of the destination, regardless the type, or the length of the overlap section. The physical front end of the train, in full supervision mode, would not be near the block section destination, due to the confidence interval limitation. In ETCS Level 2 full supervision, the overlap is for the release speed operation purpose. The occupied route, in ETCS Level 2 non-overlay, is equivalent to the calling on class, or the shunt class route, of the color light signaling system. The shunting mode in ETCS Level 2 is the feature of the onboard ETCS, but not the term for route category in the interlocking system. The unproved route, in ETCS Level 2 non-overlay, means the block section is partially proven clear by the train detection system, in the area such as entry to the depot or private railway. The unproved route is equivalent to the shunt class route of the color light signaling. The degraded route in ETCS Level 2 non-overlay is equivalent to the precede on-site authority, post-SAR class route, when at least one of the train detection sections in the block section is in the occupied state due to fault, rather than a physical object. The authorization of the degraded route is via the signalers and the procedures, but not via an automated authorization from a system. The radio block center grants the movement authority mode, based on the route category, authorized by the interlocking system. When the interlocking system authorized clear route, the radio block center grants the onboard ETCS to operate in full supervision mode. For occupied route, the radio block center grants the onboard ETCS to operate in the on-site mode. The radio block center can be configured to authorize the combination of the full supervision mode and the on-site mode for the purpose of platform sharing operation. The onboard ETCS allows the train driver to operate in full supervision mode before the station platform, then switch over to the on-site mode upon entering the platform with another train ahead. The unproved route is for the block section partially supervised by the ETCS, even though the block section is clear of object. For the entry to the depot, where part of the block section is either not proven, or proven by the interlocking system, that does not interface with the ETCS radio block center, the block section is an unproved route. The boundary of the ETCS area, and the depot area is known as the limit of authority. The onboard ETCS is in full supervision mode until the limit of authority. The full supervision mode is not available for the onboard ETCS, in level NTC. When the signaler authorized the degraded route, via the interlocking system, the radio block center grants the movement authority, with on-site mode, for the onboard ETCS. The onboard ETCS, in the on-site mode, still supervises the speed and the destination of the block section. But the train driver is responsible for initiating brake and stopping before the object in the block section. This table shows each ETCS Level 2 operation mode can apply to more than one route category. The operation mode within the movement authority information is generated in the radio block center, and the information is transferred to the onboard ETCS. The route category information is generated within the interlocking system, and the information is transferred to the radio block center. The full supervision mode applies to the clear route, the unproved route, the main class, the warning class, or the non-permissive shunt class route. The on-site mode applies to the degraded route, the POSAR class route, or the permissive shunt class route. The combination of the full supervision and the on-site modes applies to the occupied route, or the calling on class route. The shunting mode is associated with the shunting area authorization over a route category. The staff responsible mode, via the override control, is the onboard ETCS feature that is not dependent on the authorization of the route. The next section and the remaining of module will walk through the design process for establishing the requirement and the location of the typical trackside entities. Before the commencement of design process, a re-meet is essential to determine the requirement for the ETCS Level 2 trackside arrangement. The hypothetical re-meet in this section is for the purpose of this learning module only. This hypothetical re-meet requires ETCS Level 2 non-overlay, based on the requirements in the CCS-TSI, ETCS Baseline 3, MR2, and the GB Trackside Subsystem Requirements Specification, version 2. The ETCS Level 2 area will be supervised by a single radio block center and a single computer-based interlocking system. The level transition order from NTC to ETCS transition is to be level 2 only. The existing track layout is to be retained. The shortest block section is to accommodate the longest train. The maximum freight train length is 775 meters. The maximum passenger train length is 400 meters. The maximum permissible speed is 140 km per hour in the ETCS Level 2 area. The 90 miles per hour value will be used for deriving parameters in the code of practice, with the imperial units. The train detection is via the axle counter system. The detection of the berth section and the overlap section is to be separate. The accuracy of Euro-Belize fitment location, Q-lock ACC, is 5 meters. There will be no permissive working for the station platform operation. No planned start of mission at the station. Non-provision of the track ahead free for the EOA with FS mode on the approach. No big metal object in the project area. No neutral section or change of traction power in the project area. All level crossing in the project area will be closed. Provision of 10 meters allowance for the distance between the planned stopping position and the ETCS marker in SR mode operation. The next step is to establish the block section length. Block section is defined as the line between two route setting positions, RSP. This is the typical method of calculating the minimum block section length. The minimum block section length will be the 9% G emergency braking distance, for the 40 km/h ceiling speed, plus the maximum train length, plus the allowance for the distance between the planned stopping position and the ETCS stop marker. To accommodate the train length requirement, the minimum block section length is 70 meters plus 775 meters plus 10 meters, which gives total of 855 meters. The minimum 10 meters allowance is chosen for the purpose of this learning module. Next step is to establish the maximum distance between the belief groups to meet the maximum confidence interval requirement. The UK ETCS requirements specification requires the maximum confidence interval for the duration of journey to be 440 meters. Therefore, the maximum distance of the consecutive belief groups to maintain the confidence interval of 440 meters or less is 4,200 meters. The UK ETCS requirements specification also requires the maximum confidence interval, within 1,000 meters on the approach to an EOA, to be 200 meters. Therefore, the maximum distance of the consecutive belief groups, to maintain the confidence interval of 200 meters or less, is 1,800 meters. Next section will walk through the RSP marker selection process. The route setting position, RSP, can be marked or unmarked on the trackside. When the RSP is required to be marked, the RSP can be marked with the ETCS stop marker or the ETCS location marker. There are 10 questions in this section to provide guidance on the structured decision-making process for a marked or unmarked RSP. These questions are based on various requirements in the UK ETCS requirements specification. Question 1. Is there a requirement to stop at the EOA during normal train operation? If yes, proceed to question 3. If no, proceed to question 4. Question 2. Is there a release speed indicated to the driver on approach to the EOA? If yes, the RSP requires an ETCS stop marker. If no, proceed to next question. Question 3. Is there a stop if in staff responsible belief group for the EOA? If yes, the RSP requires an ETCS stop marker. If no, proceed to next question. Question 4. Is there a requirement for TARV acknowledgement area on approach to the EOA? If yes, the RSP requires an ETCS location marker. If no, proceed to next question. Question 5. Is the location for the start of the turning back train? If yes, the RSP requires an ETCS location marker. If no, proceed to next question. Question 6. Does the location require regular driver communication with the signaller? If yes, the RSP requires an ETCS location marker. If no, proceed to next question. Question 7. Is there a regular start of mission at the location without ETCS stop marker? If yes, the RSP requires an ETCS location marker. If no, proceed to next question. Question 8. Is there a platform sharing via OS mode without ETCS stop marker beyond the platform? If yes, the RSP requires an ETCS location marker. If no, proceed to next question. Question 9. Is there a requirement for providing minimal possession distance? If yes, the RSP requires an ETCS location marker. If no, proceed to next question. Question 10 is the final question. Is the geographical position information acceptable? If yes, the RSP will be an unmarked RSP. If no, the RSP requires an ETCS location marker. The proposed location of the trackside entities will initially based on the longitudinal distance information derived from the signaling plan record. The ETCS operation is sensitive to the Belize group location data. Therefore, higher accuracy of survey is essential for the ETCS Level 2 project. The maximum tolerance for the longitudinal measurement along the track from the survey is 0.5 meters. After the basic information and parameters are made available, the next step is to establish the location of the RSP and the Belize groups. This is an example of the signaling plan record. The image here is intentionally rotated by 180 degrees to align with the orientation of the adjacent plans. Similar to color light signaling design process, the initial selection of the RSP is usually relative to a junction. RSP is required on the approach side of the Micklefield junction, indicated with the blue circle in this diagram. This RSP is for managing the two routes beyond the junction. This RSP is also the EOA for the train on approach to the junction when there is no movement authority through the junction. The identifier of this RSP is Y8200. The EOA Belize group at this location requires stop if in SR command for the protection of the junction beyond the EOA. This EOA requires release speed because the planned stopping position is within 40 meters of the EOA Belize group. The planned stopping position in this case is the station platform of the Micklefield station. TARV acknowledgement area is not required for the REAMET in this learning module. The answers for questions 2 and 3 of the RSP marker selection process are yes. Therefore, the Y8200 RSP is marked with the ETCS stop marker. The location of the ETCS stop marker at this stage is still not yet finalized. It is subject to the location of the EOA Belize group. The ideal location of the EOA Belize group is on the approach side of the station to provide 225 meters SIISR trip distance before the facing point of the junction. SIISR stands for stop if in staff responsible. The 225 meters is for accommodating the emergency braking distance of the freight train when tripped in SR mode. The ideal location in this case is not practical for the train operation, because the train stops in the station platform, with the movement authority indicated with the green line in this diagram, will prevent another train approaches the other station platform, as indicated with red line in this diagram. For operation practicality reason, the EOA Belize group location is 70 meters, relative to the facing point of the junction, or the train detection section extremity. The 70 meters is the 9% G emergency braking distance for the 40 km/h ceiling speed of the SR mode. The 70 meters does not include the train overhang parameter, because the status of the train detection section beyond the EOA is not proven when the train is in SR mode. The 225 meters distance can extend beyond the facing point, as long as the distance does not cover the path of another train with a movement authority. In this case, the train in one of the three potential paths of the 225 meters distance will not encounter another train with a movement authority. However, when the train is tripped into the path number 2, which is the contraflow direction of the unidirectional line, the junction would be occupied by that train for a significant amount of time during the recovery procedure. Setting the points, or setting the route to path number 1, or path number 3, for the train on the approach to Y8200, will not resolve the situation, because the train in SR mode does not require a movement authority, with point sets in certain position. but the automatic point restoration to path number 1, or path number 3, could reduce the time of the recovery procedure after the stop, if in staff responsible incident. The provision of the release speed is finalized after the release group location with the SIISR protection is established. In this case, the release speed for the EOA is required due to the distance between the planned stopping position at the station and the EOA is less than 40 meters. The overlap section beyond the EOA is greater than 70 meters. Therefore, the location of the EOA is compatible for the maximum 40 km/h release speed. The actual release speed is calculated by the onboard ETCS. The distance from the ETCS stop marker to the PIG-1 balice is 2 meters. The minimum distance between the PIG-0 and the PIG-1 balices is 3 meters. The maximum distance between the PIG-0 and the PIG-1 balices is 12 meters. The balice symbol in this diagram depicts the PIG-1 balice. The UK ETCS requirements specification requires confidence interval of 30 meters or less on the approach to the EOA with release speed. So, 4 single balises with 100 meters separation are provided on the approach side of the EOA to maintain the confidence interval of 30 meters. The Y8200 RSP and the EOA were established in Process 1. Process 2 is to establish the preceding RSP of Y8200. The RSP precedes the Y8200 RSP, indicated with the blue circle in this diagram, is determined by the minimum block section length of 855 meters, established in the block section length section of this learning module. The identifier of this RSP is Y8207. The EOA balice group at this location requires stop if in SR command for the protection of the crossover beyond the EOA. The release speed is not required because there is no planned stopping position in close proximity to Y8207. TARV acknowledgement area is not required by the REAMET. The answer for question 2 of the RSP marker selection process is no. But the answer for question 3, regarding the stop if in staff responsible, is yes. Therefore, the Y8207 RSP is marked with the ETCS stop marker. The location of the ETCS stop marker at this stage is still not yet finalized. It is subject to the location of the EOA balice group. The EOA balice group location, relative to the Y8207 RSP, that determined by the block section length, can provide 225 meters SIISR trip distance before the danger point, which is the crossover. Hence, there is no further adjustment is required for the RSP location. The distance from the ETCS stop marker to the PIG-1 balice is 2 meters. The minimum distance between the PIG-0 and the PIG-1 balices is 3 meters. The maximum distance between the PIG-0 and the PIG-1 balices is 12 meters. The balice symbol in this diagram depicts the PIG-1 balice. At this point, the process for establishing the Y8207 RSP and the EOA location is completed. The Y8207 RSP and the EOA were established in Process 2. Process 3 is to establish the RSP for the crossover. The location indicates with the blue circle in this diagram, requires an RSP for managing the route via the crossover, for the turning back operation. The RSP facilitates the ETCS reverse direction movement approaching the crossover, then the nominal direction after the crossover. This location is a RSP, but it is not an EOA, from the radio block center and the interlocking system perspective. When the onboard ETCS does not have movement authority beyond the RSP, the EOA is the front end of the train, after changing the active cab end, for the turning back operation. The train without the movement authority from the radio block center can move closer to the RSP in SR mode, via the override function. But moving closer to observe the RSP marker is not an essential operation in ETCS Level 2. When the onboard ETCS receives the movement authority, after the start of mission, the train is authorized to operate in full supervision mode, from the front end of the train to the RSP, and beyond. The identifier of this RSP is Y8204. The RSP location requires a balice group, with the stop if in SR command, for the protection of the crossover beyond the RSP. The release speed is not required, because the RSP Y8204 location is not an EOA. TARV acknowledgement area is required on the approach side of the RSP, to enable the onboard ETCS to enter full supervision mode before the RSP, upon the departure of the turning back operation. The answer for question 2, of the RSP marker selection process, is no. But the answer for question 3, regarding the stop if in staff responsible, is yes. Therefore, the Y8204 RSP is marked with the ETCS stop marker. The location of the ETCS stop marker at this stage is still not yet finalized. It is subject to the location of the SIISR balice group. The ideal distance from the SIISR balice group to the facing point, or the train detection section extremity of the crossover, is 70 meters. The 70 meters distance is the SIISR trip distance of the 9% G emergency braking distance for the maximum SR mode speed of 40 km per hour. The 225 meters distance is not necessary in this case, because there is no freight train for the turning back operation during normal operation. The provision of the SIISR trip distance before the facing point can avoid disruption to the adjacent line after the tripped event. The distance from the ETCS stop marker to the PIG-1 balice is 2 meters. The minimum distance between the PIG-0 and the PIG-1 balices is 3 meters. The maximum distance between the PIG-0 and the PIG-1 balices is 12 meters. The balice symbol in this diagram depicts the PIG-1 balice. The Y8204 RSP was established in Process 3. Process 4 is to establish the other RSP for the crossover. The process for establishing the location of the Y8205 RSP, and the SIISR balice group, is the same process for the Y8204. This diagram shows the provision of the RSP, and the balice groups, at the end of Process 4. Process 5 is to establish the RSP, precedes the nominal direction RSP, Y8207, established in Process 2. The RSP precedes the Y8207 RSP, indicated with the blue circle in this diagram, is determined by the minimum block section length of 855 meters, established in the block section length section of this learning module. The identifier of this RSP is Y8209. The EOA Belize group at this location does not have stop if in SR command, because the probability of unable to stop in SR mode beyond the EOA before another train on the plane line is low. The release speed is not required, because there is no planned stopping position in close proximity to Y8209. TARV acknowledgement area is not required by the REAMET. The answers for questions 1 to 4 of the RSP marker selection process are no. The answers for questions 5 to 8 of the RSP marker selection process are no, but the answer for question 9 regarding the minimal possession distance is yes. Therefore, the Y8209 RSP is marked with the ETCS location marker. When the RSP is marked with the ETCS location marker, the RSP location is finalized at this stage. The EOA Belize group location coincides or is relative to the ETCS location marker. The minimum distance from the PIG-1 Belize to the ETCS location marker is 0 meters. The maximum distance from the PIG-1 Belize to the ETCS location marker is 5 meters. The minimum distance between the PIG-0 and the PIG-1 Belize's is 3 meters. The maximum distance between the PIG-0 and the PIG-1 Belize's is 12 meters. The Belize symbol in this diagram depicts the PIG-1 Belize. Process 6 is similar to Process 5 for the remaining RSP and EOA Belize groups on the plane line. The Y8211 RSP and the EOA Belize group is determined by the block section length. The distance from the planned stopping position at the station platform to the EOA is greater than 40 meters. Therefore, there is no provision of the release speed for the EOA. This diagram shows the remaining locations of the RSP and the EOA Belize group by repeating process 5. This diagram shows the ETCS location markers are not required for the RSP of the plane line block section, when the answer is no for question 9 and yes for question 10 of the RSP marker selection process regarding the minimal possession distance and the geographical position information. Process 7 is for the remaining RSP and the EOA Belize groups on the plane line beyond the RSP of the junction, established in Process 1. This diagram shows the Y8197 RSP and the EOA Belize group beyond the Micklefield junction, after repeating Process 5. This diagram shows the remaining locations of the RSP and the EOA Belize group are established by repeating Process 5. Process 8 is for establishing the RSP and the EOA Belize groups for the nominal direction of the other unidirectional line. Apply the principles from Process 1 to Process 5 for the other unidirectional line, as shown in blue color in this diagram, to establish the RSP and the EOA Belize groups. The ETCS operational direction for the other unidirectional line is still the nominal direction. There is no directly relationship between the ETCS nominal or reverse direction and the up or down naming convention. This diagram shows the RSP and the EOA Belize groups on the approach side of the Micklefield junction. This diagram shows the remaining locations of the RSP and the EOA Belize group beyond the Micklefield junction. the ETCS Level 2 non-overlay line will connect with the color light signaling line. Therefore, additional trackside entities are required to facilitate the level transition operation. The processes for establishing the trackside entities, to facilitate the Level 2 to Level NTC transition, and the Level NTC to Level 2 transition, will be in the next learning module. This is the final section of this learning module. The minimum reading distance of the ETCS Level 2 trackside entity is derived from the deceleration distance, or the braking distance, rather than the reading time. Therefore, the minimum reading distance requirement for the ETCS stop marker, or the ETCS location marker, differ from the minimum reading distance of the operational sign for the color light signaling system. In general, the minimum reading distance for ETCS Level 2 trackside entity is less onerous than the color light signal. This is primarily due to the ETCS stop marker, or the ETCS location marker, is for the lower speed degraded operation. For non-degraded operation, the information is presented on the driver-machine interface in the train cab. The minimum reading distance for the ETCS stop marker is the greatest distance of the following criteria: the service braking distance of the 40 km per hour for the SR mode ceiling speed, or the service braking distance derived from the Appendix A of GKRT 0075 for the 40 km per hour of the SR mode ceiling speed, when the service braking rate is unknown, or the service braking distance of the release speed, which is the maximum 40 km per hour for the non-buffer stop EOA, or the maximum 15 km per hour for the buffer stop EOA, or the distance between the EOA and the SVL, when release speed is calculated by the OBU. The minimum reading distance for the ETCS location marker is the greatest distance of the following criteria: 50 meters, or the length of the track ahead free TARV acknowledgement area, or the service braking distance of the release speed, which is the maximum 40 km per hour for the non-buffer stop EOA, or the maximum 15 km per hour for the buffer stop EOA, or the service braking distance for the release speed, derived from the Appendix A of GKRT 0075, when the service braking rate is unknown, or the distance between the EOA and the SVL, when the release speed is calculated by the OBU. The minimum reading distance for the identifier plate of the ETCS stop marker, or the ETCS location marker is 50 meters. When the onboard ETCS is in non-full supervision mode, the train driver has the responsibility to observe the trackside marker and stop the train before the trackside marker. The onboard ETCS is responsible for ensuring the estimated front end of the train does not pass the supervised location, SVL. This brings us to the end of the ERTMS ETCS Learning Module 8. In summary, this module provides guidance and information for establishing the location for the RSP and the EOA balice group. The example in this module shows that there are much less trackside constraints for the ETCS Level 2 non-overlay arrangement, when comparing with the constraints for the color light signals. The constraints for color light signals, such as the signaling braking distance rules for the 3-aspect and 4-aspect signals, the junction indicator requirement for junction signal, or the aspect sequence for the junction signaling controls, are no longer the constraints for the block section, or RSP for ETCS Level 2. Thank you for your interest and attention. Goodbye, and have a good day.